This is the first tutorial in a series of tutorials geared to showing you how to use Unity 3 with ElectroServer. These tutorials really start from the basics and will show you how to start from nothing and get to connecting to ElectroServer using the ElectroServer API, logging in, joining rooms, and other things. It's largely code-centric, so we'll be using C# and just compiling Unity projects and looking at log statements that log to the console to see what's going on. We're not going to be moving things around on the screen in this initial series. It's just geared to showing you the basics. So let's get started. In this tutorial, I'm going to show you how to create a new Unity project that will work with ElectroServer. We'll be coding using C#. I'm going to show you how to gain access to the ElectroServer API. We'll write code to connect to ElectroServer, capture the connection response, and we will disconnect from ElectroServer when the application quits. So this is a really good foundation for building applications that work with ElectroServer. So let's get started here. First, you're going to want to make sure that you have ElectroServer installed and running. You can download ElectroServer from the ElectroServer website. So let me just start ElectroServer. Okay, ElectroServer is now running locally on IP 127.0.0.1 and port 9899. I'm going to create a new project. And let me browse to location for that. Okay, while Unity is loading up here, let me tell you that the DLLs used for the ElectroServer API can be found in the ElectroServer installation directory. So here I have ElectroServer 5.0.1 installed, and in the APIs directory, client, C# dist, you will find a bunch of DLLs. The ones needed for Unity are ElectroServer 5 Unity DLL, Thrift, and Bouncy Castle. So we will drag those into the project panel over here. And now that those are added to our project, we'll be able to access them from our C# scripts. So let me create a new C# script. I'm going to call it main and sync the project so that we can use Visual Studio. Okay, so now that the project is open in Visual Studio, I can open the main CS file, make sure the class is named main, and now we can get started. So before we write any more code, I'm going to flip back over here to Unity and make sure I drag this main script onto the camera. Okay, now that I've done that, and you can see that it's been added here, when the application is run, this script will be run. Alright, so before we can access the API, we need to import a few packages. So using electrotank.electroserver5.api and using electrotank.electroserver5.core. And in order to gain access to all the methods and events and everything, we need to create a new instance of the ElectroServer class. So how do we let the API know what the connection settings are? You know, the server's hosted on one or more IPs and ports. The way we do that is we create a new server instance. Server is a class, and we add as many available connection instances to that server instance as we need. In our case, we're just going to add one. So first, let's create a new server class. server equals new server, and just give it any name. I usually call it just server 1. And we'll create a new available connection instance. And we'll give it a host name, which is the IP, and port 9899. And there's a third parameter here, and that is available connection.transport type. And there are a few types here you can see. You can learn about these various types on our website. We're just going to choose binary TCP because that's the most common. And now let's add that to the server. So server.add available connection. And now the server knows about the available connection. And finally, we'll add the server to the es.engine class. Add server. Now that the API knows about the available connection, we can just tell it to connect. es.engine.connect. Now, if we were to run this code like you see here, this would work. This would connect to ElectroServer, but we wouldn't know that it actually worked because we're not listening for any events yet. So we'll want to add an event handler. So there's a few things that we're going to need to do before this example is finished. We need to add an event handler for the on-connection response. We need to set the event dispatching to be Unity thread friendly, for lack of a better term, so that when the events are dispatched, they stay within the thread we're already working in. And we'll want to add an on-application quit event handler so that we can tell the API to close its connection with ElectroServer when the application quits. So let's actually add the on-application quit event handler first. So void on-application quit es.engine.close. So when the application quits, this line is called and the connection to the ElectroServer is closed. Now let's make sure that the API is Unity thread friendly. Let me explain this just a little bit. I don't really know all that much about threads at all, so hopefully I'm going to explain this correctly. By default, the API, the ElectroServer API, dispatches events as soon as messages are finished coming in from the server. And with my limited understanding of threads, I think that starts up a new thread, and the event handlers is processed in that thread, and that can present sort of thread annoyances in Unity. So you can tell the API to queue events so that as events come in, they're just kind of added to a queue, and then they're dispatched whenever you tell them to be dispatched. So and if you go about it in that way, then the events that are dispatched will stay within the thread of whatever line of code you told it to dispatch with. It could be a little confusing, but basically, if you add this, basically 2 lines of code, things become Unity friendly. So es.engine.queuing equals es.engine.queue dispatch type .external. By default, it's set to internal, which means they're dispatched as soon as they come in. If you set it to external, then they're dispatched whenever you tell it to. And you tell it to in the update event handler down here, es.engine.dispatch. So these 2 lines of code make it sort of Unity thread friendly. All right, so there's one final thing we need to do in order to test this example and know that it worked. We're going to add an event handler and a log statement to that event handler. So es.engine.connection response plus equals on connection response. So this method doesn't exist yet. Let's create it. Void on connection response, and it receives a connection response object. One of the properties on this object is successful, and it's a Boolean. If it's true, the connection was a success. If it's false, the connection failed. So let's log this out. Debug.log connection success e.successful toString. Okay, so what did we just add? We added es.engine.connection response plus equal on connection response. This is an event handler for the connection response. Whenever a connection has completely succeeded or completely failed, it may fail due to incorrect settings or a network timeout or something like that. In either case, this method will be called down here once we're sure that a connection has either succeeded or failed. So let's test this out. Flipping back over here to Unity, going to the console, and I'm going to execute the application. Cool, it worked. Connection success, true. And now if I unclick play, then the onApplication quit event was called, and it disconnected from ElectroServer.